Welcome to Advanced Functions MHF4U1. This is our new chapter called Combinations of Functions. In this lesson number 1, we're going to explore the characteristics of a new functions created by combining different functions. First, we need to understand what is arithmetic combinations. When you consider two functions, it could be same or different. First function f at x, and second function g of x, then you can figure out the sum, the difference, the product, and the quotient by combining these four characteristics. Okay, now, so when you are combining different functions, you could represent f plus g of x and separate it into two different functions. Okay. So this category over here on the left side, this is the arithmetic combination that you could separate into different functions to carry out the algebraic expression. Okay, so let's see. So question 1, we're given f of x, x squared minus 1, and g of x, 2 square root x minus 1. So you will notice that it's a different function. This one is a parabola, and the second one is a square root. Now, like I said, the different functions could be totally different, or they could be a same type of family of functions. So we're given a combination function, f plus g, when the input is 1. So what this means is I'm going to separate it, f of 1 plus g of 1. Okay, so what that means is I'm going to plug in 1 into x, so 1 squared minus 1. So this is f of 1 plus g of 1 is 2. I'm going to plug in 1 minus 1. And then you'll notice that 1 squared minus 1 is 0, plus 0, because it's 1 minus 1 is square root of 0, it's just 0. And so what we just done is arithmetic combination of two functions. Next, so we have a subtraction. So if I were to separate it into different functions, so it would be f of 2 minus g of 2. So the order is important. And then I will be plugging in 2 into my function f. So 2 squared minus 1, that's f, minus, into g function now, 2 minus 1. So 2 squared minus 1 is 3, minus 2 minus 1 is 1, times 2 is 2. So therefore, my answer is 1. Letter C, so we have product, f times g. So this means f of 5 times g of 5. So same thing, I'm going to plug in 5 into my f function. So 5 squared minus 1 times 2, 5 minus 1. And that will give me 24 times 4, and that will equal to 96. Okay, so lastly, we have a quotient. In this case, f, I'm going to separate it, function f of 1 divided by function g of 1. We need to make sure that g, the denominator, cannot equal to 0. Okay, so what I'm going to do is let's plug it in. Well, we figured out f of 1 was 0. And we also figured out from the previous question, g of 1 was also 0. So anything divided by 0 is undefined, so it does not exist. Okay, so we're going further now. So we are given some arithmetic combination, but this time the input is just x. So what we're going to do, we're going to separate it. So f is x squared minus 1 plus g of x is going to be 2 square root x minus 1. Now, first thing you need to do is figure out if there are any like terms. But you'll notice that none of them are like terms. We have 3 terms, 1, 2, and 3, and they're not like terms. So your final answer is just this. Next, we're given a product. So that means x squared minus 1, because the input is x, times 2 square root x minus 1. Okay, so as you can see, you can't really multiply the square root, the radical, because it's just one term. So I could just make it a little bit more simple by putting 2, the coefficient, at the front. So 2 x squared minus 1 and x minus 1. So these two means exactly the same. Okay, but I just made it a little bit more organized by putting coefficient at the front. And that will be your final answer. Now, so what about the domain when we're combining different functions? Now, domain, when you are adding or subtracting or multiplying, there is an intersection of the domain of f and g. Now, intersection, we represent it using this way. Okay, so that means the domain of function f intersects with domain of function g. So as you can see where they overlap, this is the part that they will intersect. Okay. But if we're looking for the domain of the quotient combination, that means domain of the function f intersects with the function g, but keep in mind, we need to state the restriction that the denominator cannot be equal to 0. Okay, so let's do question number 2. So we're given f of x, x squared minus 1, and g of x, x minus 2, which is a square root, and find the domain of the following combination. Now, so we have addition, subtraction, and multiplication. They pretty much have exactly the same thing, right? Which is, we understand the domain of function f will intersect with domain of function g. Well, let's figure out the domain function f. It's a parabola. That means it's going to be something that looks like this, at -1. So for any parabola, x can be any real number. What about the domain for function g? Now this is a square root. So it's starting at, the 0 in this case is 2. You take the opposite. From 2, it looks like this. So it looks like domain is that x can be any real number, but there has to be a restriction. X has to be greater than or equal to 2. Okay. So if I want to write it in the set notation, it will be -infinity to infinity. And this one will be square bracket to infinity. Okay. So therefore, where would they intersect? Well, they will definitely intersect starting from 2. Because this, if I have to draw a number chart, for this one, it could be any real number. So this is for function f. But for function g, it starts from 2, and then it goes this way. So where do they overlap? They will start overlapping from beyond 2. So therefore, the domain is going to be 2, infinity. This is the domain for the following all 3 of the function. Now, what about the quotient? So quotient, we said they will intersect exactly the same, okay? So same thing for domain, it's going to be same idea, but we have to keep in mind the function g, for the first one, it cannot equal to 0. So therefore, if we don't want the function g, the domain was 2, infinity, and function f was infinity to infinity. Okay, but g is in the denominator, so we don't want g to be equal to 2, or else if it's 2, 2 minus 2 is going to be 0. So therefore, it's going to be an open circle and 2, infinity. That will be my domain for the quotient. For this one, it's same thing, but this time we don't want f to be equal to 0, right? But if you look at f, function, the domain is any real number. So there's no restrictions on it. So therefore, domain, it's from, it can include 2, infinity. Okay. Question 3. The function f has the x-intercepts -1, 1, and 3, and the y-intercept 4. The function g has x-intercept -2 and -1, and the y-intercept is 1. So find the x-intercept and the y-intercept of the following combination. Okay, so first what I'm going to do is let's make a table of values just in organized form. So this will represent x-intercept, and this will represent y-intercept. So for the first function, x-intercept is at -1, 1, and 3, and y-intercept of 4. And this is function f. Now for function g, x-intercept of -2 and -1, and y-intercept of 1. Now once you have the table values, then where they x-intercept and y-intercept, they combine, intersect, will be much easier to figure it out. So we are given product multiplication. So that means x-intercept is going to be overlapping -1. You're multiplying. So -1, 1, 3, and -2. And -1 repeats itself, so you don't have to write it. Okay. Now for y-intercept, all you need to do is multiply 4 times 1. So therefore, y-intercept is going to be 4. Okay. Next, so we're given quotient, function f divided by g. So for x-intercept, so it's going to be one that does not overlap. So it's going to be 1 and 3. Okay. And then y-intercept is going to be 4 divided by 1. So therefore, the y-intercept is going to be 4. Now keep in mind, how do I find the x-intercept? Well, we don't want the denominator to be equal to 0. So if you look at the x-intercept for g, it's -2 and -1. So we don't want the x-intercept to equal to -2 and -1. So the only possibility for x-intercept is 1 and 3, because -1 repeats itself at g, and it's going to give me undefined. So therefore, x-intercept is 1 and 3 only. But for y-intercept, all you need to do is just carry out the operations of the combination function. Let me give you one more question to try. So letter C, if we're given g over f at x. So now for this one, I have to find x-intercept and y-intercept. So for x-intercept, we understand that function f cannot equal to 0, or else it's going to be undefined. So therefore, we have to look at function g. So g, we have -2. It doesn't repeat for f, so -2. But if -1, it repeats in function f. If I were to write -1, then f is going to equal to 0. So the only x-intercept for this one, it will be just -2, because we don't want f to be equal to 0. For y-intercept, you're going to carry out the operation. So function g, y-intercept is going to be 1 divided by 4, and that's it. And that will be your final answer.